Hi Ma, good morning to everyone. Today our class is to discuss very short answer questions in our ray optics chapter. In tomorrow's class we will discuss 3 questions and yesterday's class we will discuss 3 questions and today's class we will discuss next questions. The first question and fourth question is nothing but what is Metropia, how can it be corrected? This is the very short answer and very important. Metropia and the hypermetropia, these two are the very important short answers, 2 marks questions. So what is Metropia, how can it be corrected? Metropia is nothing but a short sight. Idea untadi kadane, sight, long sight, short sight. We can use lenses by removing it. So which type of lenses are used by decreasing this type of defect? Okay, the question is what is Metropia, how can it be corrected? So it is a defect of eye due to which a person can see nearer objects clearly but cannot see far away objects clearly. So nearer objects can be viewed clearly but longer distance on objects cannot be viewed in clear manner. So this type of defect is nothing but a Metropia. So it will be corrected by using a concave lens in appropriate ranges between eye and the object. So why? Because we are using spectaculars, lenses. We are placing here, your power is 2.0, 1.5, 1.8 something. So the appropriate range of lenses are used in between our eye and the object. So this is also called as the short-sightedness. Short-sightedness. So it is also known as the far point of eye shifts from infinity to a nearer distance. Our eye is choosing nearer places and far away places, but this defect is due to the far position can be shifted to the nearer point. That's why the far point of eye shifts from the infinity to the nearer distance. So this defect can be due to this reason. So correction of this defect. This defect can be removed by using a concave lens of appropriate range or power between eye and the object. So see here, the diagram will be observed here. This is the portion P and this is our eye. This is the retina part. Actually the defect, the short-sightedness, why we are saying this is short-sightedness? The image formed is in front of the retina rather than on it. Here formed, the image can be formed here. Actually the formed portion is here on the retina, but the image can be formed here in front of the retina. So this defect is known as the short-sightedness or myopia. So by using, this is the defected eye. The image can be found in front of the retina, not rather on the retina. So we can use by detecting this, by removing this defect by using concave lens. Concave lens is placed, the image is formed on that P1, the in front of the retina and on the retina P1. But this defect can be rectified by using concave lens. This is the concave lens, this is the retina, the image is formed on the retina. Okay, this is the corrected defect. And next one is what is hypermetropia, how can it be corrected? This is known as the long-sightedness. That means near items are not clearly viewed but far away items are clearly viewed. So it is a type of defect in eye. In such a defective eye, image is formed behind the retina. It is also called as the long-sightedness. This defect can be rectified by using the convex lens. This is our eye retina, this is the object, the image is formed behind the lens, the image is formed behind the retina. This is the retina, behind the retina the image is formed. This is the defected eye. But we are using convex lens, the image is formed on the retina. Here the image is formed P1 by using convex lens. This is the correction of defect. So this is the long-sightedness. So our 2 short answer, what is Metropia and how it is corrected. The Metropia is a short-sightedness, that means the image is formed on retina but this defect is due to the image is formed in front of the retina. So this is known as the myopia defect and it will be rectified by using the concave mirror of appropriate power between the object and the eye, and it is also known as the short sightedness. And next one is the hypermetropia, and how it is correct. Hypermetropia is nothing but a long sightedness. This is due to the far objects are clearly mentioned but near places, near points are not clearly mentioned. This defect is rectified by using a convex lens of appropriate power between the object and the eye. So the image is formed behind the retina, but the image is formed on the retina, but in this defect the image is formed behind the retina. So this defect can be removed by using the convex lens. This is the hypermetropia and it is corrected by convex lens. And next we will discuss the another questions. And the next one is the what focal length should the reading spectaculars have for a person for whom the least distance of vision is 50 centimeters and the distance of normal vision is 25 centimeters. So in this least distance and the normal vision will be given, and further by using these two we can find the focal length. So the least distance of the vision is taken as V, and the normal vision, the distance of normal vision will be taken as U. Here the negative sign indicates in these lenses we have some properties. So the direction will be taken perpendicular to the incident line, it will be taken as negative sign. So here we will take U will be equal to minus 25 centimeters and V equal to minus 50 centimeters. So the negative sign indicates the directions. Okay, now the focal length can be taken as by using the formula. We know that 1 by F equal to 1 by V minus 1 by U. V is the distance, V is the least distance of vision and U is the normal distance of normal vision. So 1 by F equal to 1 by V equal to how much? Minus 1 by 50 and minus U equal to minus 1 by 25. 1 by minus 25. Then 1 by 5 F equal to how much? 50 is the LCM. 1 minus plus 2, 1 by 50 plus 1 by 50. 1 by F equal to 1 by 50, that implies F equal to 50. F is equal to 50 focal length. So the focal length is positive. Hence the correction lens is nothing but a convex lens. Otherwise it is the focal length is negative, it is a concave lens. The correction lens is a concave lens, but here we will get a positive focal length. That's why the corrected lens is a convex lens. Next, what is optical density and how it is different from mass density? Everybody knows the mass density. Mass is nothing but a mass density. Mass density is nothing but mass by volume is nothing but a mass density. So optical density means the property of the medium to slow down the speed of light. To slow down the speed of light is nothing but a optical density. The property of the medium. Optical density is the medium yokka property. The optical density is a property of the medium to slow down the speed of the light is called optical density. That means this is a medium. The light can be passing in this way. This is it will be decreased by entering this medium. The light will be passing through this is less. So it will decrease as the speed of the light through this medium. That defect is nothing but a optical density. Optical density is the property of the medium which slow down the speed of the light passing through it is called the optical density. A medium of higher refractive index has more optical density. That means the refractive index is high, that medium acts as a optical density is also high. That means it reduces the speed of the light. So next, mass density. Mass per unit volume is called the mass density, but there is no related equation for, there is no direct relation between optical density and the mass density. So next one, what are the laws of reflection through curved mirrors? What are the laws of reflection? We have two laws. The angle of incidence will be equal to the angle of reflection is the first law, and the incident light, reflected light and the normal drawn at the incidence both all are lie in the same plane. That is nothing but a coplanar condition. That is the second law of reflection. These are the three questions. Once I will repeat it, our problem we have to given the distance, normal distance, the least distance of vision, that is taken as V, and the normal distance of vision, that is taken as U. We will take minus sign. Why? Because it indicates the direction. So the focal length can be found out by using the formula 1 by f equal to 1 by u minus 1 by b minus 1 by u, v equal to minus 1 by 50, v equal to minus 50 centimeters, u equal to minus 25 centimeters. From that substitute these values in the formula 1 by f equal to 1 by b minus 1 by u, we will get 1 by f equal to 1 by 50, that implies f equal to 50 plus 50. This plus value, this positive value indicates that correction is a convex lens. And the second one is the what is the optical density and the mass density. Optical density is the property of the medium which reduces the slow down the passing of light through it. The refractive index of the medium is high, the optical density is also high. Mass density, the mass density is nothing but a mass per unit volume is the mass density, but there is no direct relation between the mass density and the optical density. And next one is the what is the reflection, what are the properties of their, what are the laws of reflection to their curved mirrors. The laws of reflection, the first law is nothing but the angle of incidence obviously equal to the angle of reflection, that means angle I equal to angular. And the second law is nothing but the incident light, the reflected light and the normal drawn at the point is all are lie in the same plane, that means it obeys the coplanar condition, that is the second law of reflection. Today your class is over, and tomorrow we will discuss another 3 short answers. That's it. Thank you.